Hello everyone and welcome to Physical Science Unit 3, Section 4, Covalent Bonding. Covalent bonding is all about sharing electrons instead of stealing. So caring is sharing. We're going to talk about elements that share electrons instead of steal electrons and becoming ions. So let's get a definition in first. Covalent bonding. This is when two or more nonmetals, which means they're on the right-hand side of the periodic table, two right-hand siders share electrons. Now they're going to share electrons to end up with a stable octet or a stable valence shell. So a single bond contains one pair, a pair is two, of electrons. So if they are sharing two, they have one bond. If they're sharing four, they have two bonds. But atoms can share multiple pairs of electrons. So notice that this one, this image right here, only has one bond because it's sharing two, sharing a pair. So that is one bond. This one, however, is sharing, so between nitrogen and nitrogen, 2, 4, 6. So it has 1, 2, 3 bonds. Now the whole point of the sharing, again, is in order to achieve stability, they all want to get to that stable nobility where they're full valence shell and they're stable and they're not going to react with anyone else. Okay, so when naming covalent compounds, so if they're sharing, we have some different rules for naming than we do for ionic bonds. So naming covalent compounds, you will use a prefix to ID the number of atoms in the molecule. So if you don't know prefixes, go ahead and write down what the prefixes are. And I would need to too, because every time I have to look at this, I have to look back at them. So 1 is mono, 2, so mono, 1. Di is 2, tri is 3, like tricycle, tetra is 4, but not like the fish, penta is 5, like a pentagram, hexa is 6, hepta is 7, octa is 8, because they're like octopus, I love octopus, nona is 9, and deca is 10. So the first rule is you use a prefix to identify the number of atoms present in a molecule. So the second nonmetal, the second element in the name, will always end in "ide." And we'll see some examples of this in a second. So if only, there is a caveat, there is an exception to the rule for using these prefixes. If only one of the first elements, or if there's only one of them in the compound, do not use mono. Now, if there are more than one, use the prefixes for the first one. Only if there is one for the first element in the compound will you not use mono. Otherwise, you will use all of these prefixes. I'll show you what I mean. Okay, so here are your prefixes. So the rule says that you are going to write the prefix for the number of elements. Well, remember, if you have N and O, it's implied that there's a 1 here and a 1 here. So there's 1 nitrogen and 1 oxygen. So, is this right? Would I write mono nitrogen monoxide? No. Now notice I chopped off the N and added IDE. What is wrong with this though, according to my rules? So let me back up. It says, use a prefix to identify the number of atoms present in the molecule. Okay, I did all that though. Oh, but wait, there's a star. Oh, and I did the second one ends in IDE, but if there's only one in the first element, do not use mono. Guess what I did? I used mono. So would I do that? No. This would actually be nitrogen monoxide. Now you may be wondering, well, why did she use mono there? Because it's not the first element in the name. It only says don't use mono if it's the first element. This is the second element, okay? And yes, I chopped off the end and added IDE. So now let's try this one. It says there are 2 nitrogens, boop, 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 boop. There are 5 oxygens, boop, boop, boop. And if we do those, we need to add prefixes. So I would write the prefix for 2, which is di, and nitrogen. And then I would look for the prefix for 5, which is penta, and we would write pentoxide. Now notice I changed the oxygen in to IDE because that was the rule. Now you may be wondering why I didn't write pentaoxide. Honestly, just because it sounds weird, that's not what they write. So, because you would have a right beside an O, and what type of noise would that make? So it's dinitrogen pentoxide. So let's try this one. So we've got carbon and chlorine. Well, I have 1 carbon, because remember, if there's nothing written after it, it's assumed that there's a 1 here. So I would write carbon. Why didn't I use a mono? Because it's the first element, and that's the rule. You don't use it if it's the first element. And then I have 4 here, so I look for my prefix, which is tetra. So tetrachlorine chloride. Ooh, I spelled that wrong. Tetrachloride. So notice that I changed the INE to an IDE because those are the rules. All right, so let's try these. How do we go backwards? How do we take it from writing the names to writing formulas? So writing formulas, and we're going to get these examples in. And then I look at this, and I see it says diphosphorus. So I know it's phosphorus. I look on the periodic table to find that phosphorus is P. And then I see that it says di. So what is that prefix? 2. I put a 2 after it because I have 2 of them. And then it says pentoxide. Well, oxide is for oxygen, and penta is for 5, so I write a 5 after it because there's 5. Done. Boop. All right, next one, sulfur. Sulfur is S. Do I put anything after it? No, because remember, if it were mono, you may be wondering, well, how many are there? Well, if it's mono, you don't put anything in front of it, so it's assumed that it's a 1. So you just write the sulfur, because remember, if there's nothing there, you just assume there's a 1 after it. Hexafluoride. So fluoride is fluorine. And then I look for how many there are. And I go, okay, well, if it's hexa, well, then hexa's over here. It says 6. I have 6. Done. Now moving on. Dinitrogen tetroxide. Di means 2, and nitrogen. So nitrogen, and there are 2 of them. Remember, if you have a subscript, it means that there are 2 of them. Tetroxide, so oxygen, and then tetra is 4, so N2O4. All right, I'm excited about naming, and you guys have a wonderful day.